Go ahead and open your books to page 35. We are starting a new activity, and it's called Solving Inequalities. So we're going to be in Lesson 3.1 today, which is all about inequalities and their solutions. So our first learning target today is to understand what is meant by a solution of an inequality. And then we're also going to graph solutions of inequalities on a number line. So go ahead and read this paragraph about Spartan Middle School students. They're participating in physical education testing each semester. So some of you might do this here at the high school every trimester. So in order to pass, 12 and 13-year-old girls have to do at least 7 push-ups and at least 4 modified pull-ups. They also have to run 1 mile in 12 minutes or less. So there are 3 different requirements here. And if you take a look at this table, it's going to show us 3 different representations of the same thing. So we just read that they need to have at least 7 push-ups. So there's the verbal description. And then the inequality is P, push-ups, has to be greater than or equal to 7. And then you can see it graphed on the number line right below. So I have a dot at 7, 8, 9, 10, 11, etc. Again, for pull-ups, we need to be at least 4. So M is greater than or equal to 4. They're using an M for the word modified. Notice how we have points again at 4, 5, 6, 7, 8, etc. And then we see our mile time, 12 minutes or less. So this run, R, needs to be less than or equal to 12. And we have a shaded area on our graph, or also called a ray. So, question 1, I want you to write down what you think. So, you might need to pause the video, but why do you think the graphs of push-ups and pull-ups are dotted, but the graph of the mile run is a solid ray? So the answer to this is, if you're thinking about push-ups and pull-ups, and maybe you're in gym class or you're at a workout for a sports team, if you do 3 pull-ups and you're halfway up and you can't quite make it, you're not going to write down that you did 3.5. You're going to write down 3. You didn't quite make it to 4. Same thing with push-ups. If you're halfway down and you fall, that doesn't count. So the reason here is that push-ups and pull-ups are always completed or counted using whole numbers. But if you're thinking about running the mile, which I know some of you just had to do outside on the track, running time is continuous, right? If you get a mile time of 10 minutes and 42 seconds, we're not going to round down to 10, and we're not going to round up to 11. You're going to get that exact time of 10 minutes and 42 seconds. So you can write that down, that running time is continuous, and we want it to be accurate and precise, so we're not going to necessarily have whole numbers every time. Question 2, we're going to look at a specific student here. Her name is Jamie. Jamie ran 1 mile in 12 minutes and 15 seconds. She does 8 push-ups and 4 modified pull-ups. So think of the requirements up above in that first paragraph. Does she pass? Yes or no, and then explain. So her 8 push-ups count, that's at least 7. Her 4 modified pull-ups count, that's at least 4. But remember, our mile time has to be 12 minutes or less. So this is no because of her mile time. Has to be 12 minutes or less. Question 3 has a new student named Karen. Karen did 7 push-ups. Go ahead and answer question A. Remember to pause if you need to. Is this a passing number of push-ups? Yes or no? Then which words in the verbal description from our table indicate this and explain? Yes, Karen passes. How do I know if I go back up to my table and look at the verbal description? I know because of the words at least. She needed to do at least 7, which indicates that 7 is a passing number. So maybe we should add in at least 7. But how is this passing number of push-ups represented in this inequality right here? Well, if I look at my symbol, this is greater than or equal to. So this right here is really important. This line underneath, that means or equal to. So this symbol tells us that 7 is an answer. We can include 7 as a solution. On the next page, for question 4, we're going to use this table to figure out whether or not these x values are solutions to this equation right here and this inequality right here. So you're going to have to plug in these numbers. So again, you're probably going to have to pause. Use your calculator to help you if you need it. Okay, so I will walk you through the first one. Instead of having an x, we're plugging in -1. So again, we need to substitute, plug in. So it would be 2. Instead of having an x, we're multiplying by this -1 plus 3. 2 times -1 plus 3. What do we get? It says it should equal 5, but we get 1 equals 5. That's a false statement. So no, -1 is not a solution. So if I go over to the next column, you should notice that I still have 2x plus 3, but this time I have a greater than 5. So when we plugged in a -1 here for x, we plugged in a -1, we got 1, and then we need the symbol greater than 5. So notice I didn't have to do the work again. I'm going to just use my answer from the first column. So is 1 greater than 5? No, so it's not a solution. And we need to keep going. So now you're going to plug in 0, yes or no, for the equation and the inequality, and then you're going to do the same thing for 1, 2, and 8.5. So go ahead and pause and do that. So here we get 3 equals 5. That's a no. Is 3 greater than 5? No. When we plug in 1, we get 5 equals 5. Yes, that's a true statement. So that means 1 is the solution to this equation. Over here is 5 greater than 5. Be careful. This is no. The next one, when we plug in x equals 2, we get 7 equals 5. False statement, so this is no. Is 7 greater than 5? Yes. When we plug in 8.5 for x, we get 20 equals 5. No, that's a false statement. Over here, we get 20 is greater than 5. Yes, that's true. So it's a solution. So if we look at these two columns for question 5, how many solutions are there to the equation? So how many times did we say yes? Just once. There is only one solution. What is that solution or the answer? It's x equals 1. That's the only time we made it a true statement, the only time we wrote yes. So if we're looking at our table, which numbers are solutions to the inequality? Well, we got x equals 2 and x equals 8.5. Do you think that these are the only two answers or solutions to this inequality? Well, let's try to plug in 5. 2 times 5 is 10 plus 3 is 13. 13 is greater than 5. Yes, so that works. So x equals 5 is an answer. So are these the only two solutions? No. In fact, you can write this down. Any number greater than 1 would be or is a solution. Any number greater than 1. Because here we got no when we plugged in 1, but we got yes when we plugged in 2. We plugged in 5, it was yes. 8.5 was yes. So any number bigger than 1 is going to work. Ooh, they're going to change it up here. Would 1, or x equals 1, be a solution to this inequality? Ooh, the symbol is different here. 2 times 1 plus 3 is greater than or equal to 5. We get 5 is greater than or equal to 5. Because we have this or equal to line, then yes, it is a solution. Now we can be or equal to 5. They changed the symbol on us. What I would like you to do is definitely pause the video here, please. And I would like you to answer similarities and differences in that table. So you have two different number lines. Okay, this one is x is less than 3, and it's graphed. Then we have x is greater than or equal to -2. So what I would like you to do here is write down the similarities and the differences that you notice between these two things. You can talk about the inequalities and the symbols. You can also talk about the number lines. So come up with at least 1 or 2 similarities and at least 1 or 2 differences. Bonus points if you can be the student that has the most similarities and differences. So go ahead and write those down. And then when you come to class on Thursday, we will talk about what you wrote down and we will finish the other 2 questions here.